The concept we're dealing with today is Hess's law. Hess's law states that, it's a law of thermodynamics, it states that if you have a reaction A going to B, and you don't know what the enthalpy of formation of this reaction is, and if you had a different pathway where A goes to C and C goes to D and D goes to B, while this might be roundabout, if you did know the individual enthalpies of these pathways, so this is delta H1, this is delta H2, and this is delta H3, say, then the enthalpy of this guy right here, A to B, would simply be delta H1 plus delta H2 plus delta H3. So what we're really saying is that the change in enthalpy is independent of the path taken, okay? Enthalpy does not depend, that was supposed to be a not equal to sign, the path taken, okay? So now let's try problem number 5. You're asked to determine delta H for a reaction here, which I'm going to write. I'm going to write it on top of this. CH4 plus O2 gives CO2 plus H2O. This is a classic combustion reaction. Let's finish up by balancing it out. Note that a lot of times when we do reactions, we don't write the states of matter. In this case, as we'll see in just a little bit, it's quite important to do that. So what we're saying is, we do not know what the delta H of this reaction is. But we're given we're not completely different. We're given two other reactions for which the delta H's are given. So one reaction looks very similar. So it's CH4 plus 2O2 again, giving CO2 and 2H2O. And if you're very careful, you'll notice that this is a gas, okay? And I made a mistake. The original reaction that was unknown was not a gas, but a liquid. So this is a liquid right here. So you are actually given the enthalpy of formation of a gas. And they're saying this is negative 802. I'm going to just write kilojoules per mole here because everything is in that. The second reaction that you're given is 2H2O gas gives 2H2O liquid. What kind of reaction is this? Condensation. And delta H2, and I'm numbering them as 1 and 2 so it's easier for me to keep track later, is negative 88 kilojoules per mole. Okay, so let's scroll down. How on earth are you going to get the orange equation from the two green equations? Hopefully by now it's apparent to you, but if we just add the two equations, let's just add them. Reactants add to reactants, products add to products, and everything that I've not labeled with a state of matter is basically a gas. Plus 2H2O gas. These are just like algebraic equations, so there is nothing too complex about adding or subtracting equations. In this particular question, there was no need to subtract an equation, but if we did have a need to subtract an equation, we would just flip the equation. Now, there's 2H2O gas on either side. I'm going to cancel it. And so that leaves me with the reaction that was required in the first place. When you can add two reactions to get a third reaction, you can do the same thing with the enthalpy. So the enthalpy is delta H1 plus delta H2 is your new enthalpy, which is just negative 802 plus negative 88 kilojoules, which is negative 890 kilojoules per mole. Hope that makes sense.